In this problem, I'm going to revolve this region bounded by the fourth root of x and the line y equals x about a vertical line. So we're going to revolve it around the line y equals 1. That would be this line here. I'm sorry, x equals 1. So I wrote it right, I drew it right, I said it wrong. And this is actually drawn very badly too. It's actually a line, whatever. So we're going to revolve this around, and we're going to do this with the washer method. So if I draw like my cross section, say it's something like that, more or less, and then I'm going to draw my washer so I can kind of imagine what my washer is going to look like here, right? So you can see that, of course, we are going to be integrating with respect to y because the thickness is in the y direction. So what we have is that the volume is pi times the integral of the outer radius squared minus the inner radius squared, and thickness is in the y direction, so we've got dy. So then what? Well, we have to figure out what the outer radius and the inner radius are. So let's just kind of think about that. Regardless, maybe it would be easier if I just thought about, say, one of them. Let's do the inner radius. For the inner radius, we want this distance, right? So this whole distance is 1, but this distance is, of course, x, right? Because we're going x units out along the x-axis. So I can think about that inner radius as being 1 minus x. And then really I want it in terms of y. This line is the line y equals x. So I'm going to put x inner, right? And then that's just going to be 1 minus y. If I'm going to the outer radius, it's still going to be 1 minus x. It's just a different x because it's a different formula. So I can write that 1 minus x outer. So I'm going all the way to this curve. This is still the x for that curve. So that then becomes, okay, I have to solve this, right? So I basically take the fourth root, not the fourth root, I raise everything to the power of 4 because I need to put it in terms of y. So then this is going to be 1 minus y to the 4th. Okay? Now if I put I still need some limits. The limits are from 0 to 1. That's, of course, where these two are going to cross. So it's 0, 0, and 1, 1. So the limits look the same whether it's in x or y. So I put this in here. I don't have that much space. Let me, I guess, erase it. Let's put a little bit more over here. Pi integral from 0 to 1 of r out squared minus r in squared dy. So that was going to be this guy, 1 minus y to the 4th, and then minus this guy, 1 minus y quantity squared. And then this integral isn't hard to do. Just kind of work all those things out. So I end up with 1 minus 2. Oh, but I did want to kind of point something out here. Easy mistake to make with all of these because especially when it's moved over because you've got something minus something or whatever. Don't forget your parentheses in this second one because it will mess it up. You'll get the wrong sign. You'll get the wrong answer, right? Because this has to distribute. So that's an easy thing to forget to do. Yeah, because I forgot to do it. I got a negative answer. I'm like, what? What did I do? And I found it. It's always a negative in the wrong place with me. Anyhow, so you do all this. I'm not going to bore you with it. You can do it yourself. The answer, which I had figured out here somewhere, yes, 17 pi over 45 is the right answer for this problem. And that works out if you do that integral correctly, which you should be able to do because it's just a quadratic. No, polynomial, rather. So this is the kind of the idea. It's always going to be, if you are rotating around something that's not one of the coordinate axes, it's always going to be somehow the number minus the other thing, or this minus the number, or whatever. So it's going to be something like that always. Minus negative something, right? For example, we could do the same problem, but instead we could do it over here. Let me just set that something up like that up. So let's say instead of going about this line, we wanted to go around the line x equals negative 2. So I have to change my picture a little bit. This isn't going to give you the idea. I'm here, and then I'm over here. So I'm going around this way, and now my thing is very big, right? It's gonna look like this, right? So my outer radius is gonna be to that, and my inner radius is going to be to this. And this distance, of course, is 2. So if I want to switch that up, my outer radius is going to be 2 plus x. And my inner radius is also going to be 2 plus x, but x inner. And so the other thing that's happened is, because we're going the other way, they've swapped, right? So the outer one is now the y equals x. So this is going to be 2 plus y. And the inner radius is the curve. So that's going to be 2 plus y to the 4th. So outer minus inner. So really, having the picture is pretty important, is very important, just to figuring it out. Okay, and I'll just leave it there. I'm not going to go ahead and evaluate that one, but that's the whatever it is.